All right, Algebra 2, if you made it this far, then you're doing okay. We're going to take what looks like big problems, right, and we're going to slap them together and make a problem out of it. And I'm going to give you some shortcuts, so maybe that's going to be a little bit easier. Maybe not. You guys give me the feedback when we get together in class. All right, so here's the bottom line. We're going to take radicals. Those are square roots, in case you didn't figure that out by now, right? Square roots, cube roots, fourth roots, whatever they are. All right, so a couple of vocab things. We should probably address this. This is the index, right? So this tells me the 1/2 power, the square root, those type of things. This tells me the root. We're simplifying radicals, tells me how many to look for. If it's a square root, I'm looking for pairs of 2. Cube root, groups of 3. Fourth root. Now, here's the shortcut for today. I'm going to ask you to multiply and divide some things. I can only do that when those indexes are exactly the same. So if they match, I can actually put these together. A times B goes inside of here. Now, we're not always going to write it that way because I'm going to ask you to simplify on top of it. So for the sake of what we're doing here in Algebra 2, we won't always do that. All right, but this is what this is saying. So the same as exponents, right? If you had 2 squared and 3 squared, you could actually make that into 6 squared. We don't deal with that too much in dealing with exponents because it makes the numbers larger and order of operations. We're just going to go ahead and square those first and deal with it that way. Now, if you're using a calculator, that's a pretty good rule to know. All right, so the same thing for an index. Remember, if there is no number in here, this is like a 2. We could write it in or we can leave it out. Remember that. Empty means 2. So how are we going to use that? Okay, so if I look at, well, in A, first, checking the indexes. Do they match? No? Okay. Then can I simplify it? No. No, I could say no. I could say it is simplified. Okay. I wouldn't say no solution. I would say this is all that I can do with it. Now, if they just want me to simplify the product. So what could I do with it? I could get a decimal value and multiply it by this decimal value. But for the sake of what we're doing, I just want you to make sure that those indexes, right, that they match. All right, next one we have, I see an index of 3 and an index of 3. So that means I can put these together. So I want the cube root of -8. All right, so that's something we can break down. Remember, I'm always going to use a third one. So -1 is definitely coming out of here. 8 is made up of 2 and 4, and that's 2 and 2. So I get a trio of 2's. So that means this final answer is -2. Right? The cube root of -8 is -2, right? Double check, -2 times -2 times -2. That's -8. All right, in part C here, I check my indexes. They're the same, which means I can put these together. And here's what I mean. I don't want you to put those completely together all the time. I'm going to make this into one big problem. So 8 times 4. I'm going to put my x's together to make it x cubed and y to the 6th. Okay, why did I leave the 8 and the 4? Well, because I'm dealing with square roots. And if I can make this 2 and 4, I already have a pair. So I know it's going to be 4. I'm going to leave some space for x's and y's. Square root 2, because the 2 was left over. If I have x to the 3rd, that means I have one pair with one left over. And if I have y to the 6th, right, I have 3 pairs, there are none left over. So that's what we're going to deal with as we break that down. So just because I know, right, I know by all means you guys are super good with multiplication. You know this is 32, but the first thing you're going to do after you do that is break it back down again. So I encourage you as we work on these to leave the numbers separated. Right? I know I didn't do that in B, but we're trying to get the idea. Okay. Since we're going to simplify afterwards, we're going to go ahead and do it that way. All right. So let's see if we got it here. Okay, so what you're going to do is give yourself a quick pause here, double check, and when we get back together. Right, you paused? Okay. Hey, welcome back. All right. My indexes don't match. Okay. So this is simplified. Right, so this one's done. There's nothing else we can do with it. Right, notice we're trying to use that distractor. Right, the radicand, the thing we're taking the square root of here, their 4th root, 5th root, they match, but it's the indexes that are super important. All right, and the next one, so this is the 5th root of -2 times -5 is +10. All right, and there's nothing we can do to break that down anymore at this point. All right, so simplifying that product. Oh, was there a third one? Nope, just those 2. Look at that. It's going to be an easy day, right? All right, so here's what I mean. I don't want you to put these together, right? It seems like a lot of work. Okay, so this is 72 and 10. I am going to put my x's together. So I get x to the fourth and y to the fifth. Now I want the square root of that. So that's kind of the beauty of this whole thing is I really don't need you to run through all the hoops to get there. So this is 2 and 5. So is there a 2 in 72? Well, it sure is divisible. So let's see, half of 72, that'd be 36. All right, well, that works out pretty nice because I get a pair of 6s and a pair of 2s. All right, so that means on the outside I have a 12 so far. On the inside, leave a little space here. I have the square root of 5. And then we're going to work through our x's. 5x to the fourth, how many pairs? Right, because the index was 2. I have 2 pairs. And then the last thing we're after is y to the fifth. That means I get 2 of those, but there should be 1 left over as well. Okay, so you can see how, obviously, we can make this into 720 multiplying, but it's going to be a whole lot easier if I just leave it separated and then work through our factor tree there. Okay. Number 3, this one's a little tight in space, so let me zoom in a little bit more. This multiplication would be much easier, so let's just leave it at 45 and 35. X to the 6th, y to the 7th. Okay, so one thing that I know is definitely in common here, so I'm going to write them this way. All right, so 35 is 7 and 5, 45 is 9 and 5. Just don't forget 9 gives me a little set of 3s, and I got a pair of 5s here shared between the two. So what's on the outside? 15's on the outside. What's on the inside is 7. Okay, so if I go ahead and multiply 35 and 45, this becomes a mess. All right, so it's a lot easier to leave them separated. I can't say that enough. Okay, now I said it enough. I'm not going to say it anymore. All right, x to the third, it was an even number, so it divides evenly because the index was 2. And as we look at y to the 7th, I'm going to get 3 of those. It gives me 6, and 1 more makes 7. So that's our easy way to double check those numbers. Okay, so that's what we do when we're multiplying. We are going to make it into one big problem. Your choice, whether you actually multiply it or not. I'm going to choose not to, and I like my choice. Next thing is if we're dealing with a fraction, this is the same thing as saying 18x to the fifth over 2x cubed. So what I want to do by putting it back together is actually divide and then divide. So that's why we reviewed our exponent rules here recently. So this becomes 9x squared. Don't forget that this is covered by the square root. So instead of having this whole mess trying to figure out what to do with 18 and the top and the bottom and all those things, now I just have the square root of 9x squared, which is 3x. So it simplifies into something that we can actually work with. Let's see if that happens here. They're both under the cube root. So I am picturing in my head, actually I'm going to write it out here, that this is actually one big fraction. I know the y's are going to work out nicely to y cubed. Let's see about 3 into 16, so that's 5, and that's 12, 54. Okay, so now we're dealing with the cube root of 54 and y cubed. So let's see what happens here. Y cubed is going to work out nicely, but we're going to work through this number first. 54, what do you think there? 9 and 6. So I get 3 and 3 and 3 and 2, all really close, right? So 27 would have worked in there. So that means I have a 3 on the outside. I have y on the outside. I have the cube root of the only number left over is 2, and there are no variables left over. Okay, but I got to make sure I have that index hanging in here, because if we write square root, then automatically it's not the same as what it was, which makes it incorrect, right? So would that be the correct answer if I put a square? Nah, not going to happen, right? All right, the last one we're going to have rationalizing the denominator. Hey, sorry if you're not in my class. We'll deal with that as we run into it later this year, but we're just trying to get the simplifying radical part together, and we'll deal with that.